Hi, this is Alex from devstories.eu. OpenCV Computer Vision Deep Dive, Episode 7 of 20. You can rip the brain out of a massive PyTorch training server, export it as a single file, and run it blazingly fast in pure C++ without installing PyTorch at all. When you transition from training a model to deploying it in the real world, your requirements flip from flexibility to raw speed. This is exactly where the Inference engine, OpenCV's DNN module, takes over. A common trap engineers fall into is assuming that if a model was trained using TensorFlow, the target deployment machine must also have a heavy TensorFlow installation to run it. This is false. OpenCV executes the inference entirely natively. The DNN module is a dedicated, highly optimized forward-pass inference engine. It does not do backpropagation. It does not calculate gradients. It does not train models. Its only job is to take a pre-trained network, ingest an image, and give you an answer as fast as the hardware allows. OpenCV provides native loaders for standard model formats. You can load Caffe models, TensorFlow protocol buffers, darknet configurations, and ONNX files directly into your application. Here's the key insight. When you call a function like readnet, OpenCV parses the external file format and reconstructs the neural network graph using its own internal C++ layer implementations. The external dependencies are completely stripped away. Your application only links against OpenCV. Consider an embedded C++ smart camera designed to detect pedestrians on the street. You do not want a massive Python runtime consuming your limited memory, and you certainly do not want gigabytes of deep learning libraries taking up storage space on an edge device. Instead, you train your pedestrian detector on a heavy GPU cluster and export the final weights to an ONNX file. You drop that single file onto your camera's storage. In your C++ application, you use the DNN module to load the ONNX file. Next, you capture a frame from the camera's sensor. Neural networks cannot process raw images directly. You must convert that frame into a structured four-dimensional array, commonly called a blob. OpenCV provides a dedicated function to build this blob, which handles resizing the image, swapping color channels, and applying specific mean subtraction or scaling that the original model requires. You pass this prepared blob to the network's input layer. You then call the forward function. The DNN module takes over, pushing the data through every convolutional layer, activation function, and pooling layer. Because OpenCV owns the entire execution graph at this point, it can aggressively optimize the math. It fuses adjacent layers where possible to reduce memory bandwidth and targets native hardware acceleration automatically. The forward function finishes and returns a final array containing the bounding box coordinates and confidence scores for the pedestrians it found. Keep your heavy frameworks in the lab for training and use OpenCV's DNN module for lightweight, dependency-free deployment and production. Thanks for hanging out. Hope you picked up something new.